Hello everyone. Our group will be presenting our GD&T examination on a spotting scope lens assembly, which includes two primary components, a barrel housing and a doublet lens. The barrel housing consists of a threaded cylindrical tube with different upper and lower section diameters, separated by a 45-degree chamfer, which acts as a seat for the lens. The lens has a matching chamfered bevel that allows for seated contact with the barrel without the optical surface coming in contact with the housing. One of the main concerns in this assembly is ensuring the accurate alignment of the lens within the barrel. Even the slightest misalignments can lead to pinching and optical distortion, reduced image sharpness, or improper focusing. In addition, the lens must fit securely without excessive play, while allowing for thermal expansion and ease of assembly during manufacturing. In the first drawing of the main barrel of the lens, there are a total of two datums that are perpendicular to each other and act as a reference for geometric control during manufacturing. Datum A is defined as a flat plane on the bottom of the barrel, with it placed upright. This is critical because it serves as the primary reference for orientation. It ensures the entire assembly is seated flat and level during both manufacturing and final inspection. Our chosen value of 0.01 millimeters is quite a tight value. However, this is needed to make sure the lens is not misaligned in any way, shape, or form. With a value this small, we can assume it would be manufactured using high accuracy processes such as CNC. As depicted from the zoom-in detail section, there is a small lip inside of the barrel where the double convex lens sits. The angle of the lip must be accurately controlled to ensure consistent lens positioning and optical alignment. To manage this, we reference datum A to control the angle of the lip using angularity tolerance. Angularity is a type of orientation control that ensures that a feature or surface is at the correct angle relative to a datum within a specified tolerance zone. On a surface, the necessary tolerance zone is two planes angled from the datum. However, ours lies within a cylinder, meaning that it is dependent on the central axis. In our case, the angularity ensures that the lip surface is always at the correct angle relative to the base of the assembly, preventing lens tilt or uneven seating. Now looking at the drawing scheme of the actual lens, datum A, seen in red, is the datum axis, corresponding to the central axis of the cylinder. Datum B, seen in blue, is a flat datum plane near the bottom of the lens at the edge of the lower bevel. This is used as a reference for parallelism, ensuring the two curved surfaces of the lens remain properly oriented with respect to the datum. A profile of surface tolerance is used for both the front and back optical faces of the lens. This allows for extremely accurate adherence to spherical shape of each surface while allowing for much looser radius of curvature callout. Additionally, datum B is used to control the angularity of the bevel that mates with the respective barrel chamfer. This helps ensure that the two mating surfaces align correctly, maintaining consistent optical and mechanical alignment during assembly. To ensure enough space between the lens and the inner wall of the main barrel, a cylindricity tolerance was applied to the outer edge of the lens with respect to datum axis A. This concludes the GD&T of the lens assembly. Thank you for listening.